Okay, so this is the remainder theorem. So when you have the remainder theorem, you're trying to figure out whether something is divisible exactly or not by whatever the factor is. So there are different ways of doing this, but what I like to say is that if this is a factor, then you have x plus 4 times something will give you this 2x cubed minus 5x squared minus 6. In which case, if you solve that and put it equal to 0, then the first thing I would have is I would say, well, x would equal negative 4 from solving this equation equal to 0. So that means that if I substitute in negative 4 and this is a factor, then we're going to get 0 coming out. If we don't get 0 coming out, then we have a remainder. And that's what we're looking for here. We're looking for the remainder. So I am going to try. So let's call this expression here f of x. And I'm going to try substituting in negative 4. So f of negative 4. So that will give me 2 lots of negative 4 cubed minus 5 lots of negative 4 squared plus 8 lots of negative 4 minus 6. So we can do that all on the calculator. 2 lots of negative 4 cubed excuse me, minus 5 lots of negative 4 squared plus 8 lots of negative 4 minus 6 gives me a remainder of negative 246. Okay. In the same way, if I want to show that x minus 2 is a factor, then that means the value I need to substitute in is going to be what makes x minus 2 be equal to 0. So I'm going to substitute in x is 2. So I'll try f of 2. So this is 2 cubed plus 9 lots of 2 squared plus 8 lots of 2 minus 60. I'm just going to put a bit more detail into this one. 2 cubed is 8. 9 lots of 4 is 36. Plus 16 minus 60. Well, these will add up to 8. Plus 36 is 44. Plus 16 is 60. Take away 60 is 0. So f of 2 is 0. And that implies that x minus 2 is a factor. Okay, then we're going to hence factorize this cubic. So we now know, because this is a factor, x minus 2 is a factor, then this is x minus 2 multiplied by something will give me an x cubed. So in order to multiply x by something to give me x cubed, this has to be a quadratic. So some amount of x squared plus some amount of x plus c. So if I set up my grid here, I'm going to have a 2 by 3 term grid. So let me just set that up. Sorry, bear with me. That's not going to work. Thought I'd be clever. It's not going to work. Okay. So this is my grid. And the reason I've done these colours is because everything is going to match up in here. So my x cubed term is going to go in my top left. So that's going to be my x cubed. And my constant is going to go in my bottom right. So my negative 60 is going to go there. Now, these two boxes are going to make up my x squareds, and these two boxes are going to make up my x's. So they're going to make up my 9x squareds, and that's going to make up my 8x's. So let's have a look at what I've got. I already know that one of the factors is x minus 2. So I can work out this value because I know that these two multiply to give me x cubed. So x times x squared is x cubed. And that then means I can fill in this value because it is a negative 2 times x squared. So negative 2x squared. And then I know that these two combine to give me how many x squareds I want. And I want 9. At the moment I have negative 2. So I have to put 11x squareds in there. Because now 11x squared minus 2x squared gives me the 9 I want. And then I go through this again. So x times this is 11x squared. So that's going to be plus 11x. Excuse me. And then this box down here is negative 2 times 11x. So that's negative 22x. I want 8 x's. So I need to put an extra 30 x's in. And then I go again. X times this is 30. So that's going to be plus 30. And then 30 times negative 2 is negative 60. So I've done this right. So this now means that I have my x minus 2 multiplied by x squared plus 11x plus 30. And now we're going to factorise this one. Now this one is a fairly simple quadratic to factorise because there's only a 1x squared. The two numbers that we want in the brackets will multiply to give 30 and add to give 11. So those numbers are going to be x plus 5 and x plus 6. And that is this one fully factorised.